Good evening. So thank you very much for coming tonight. My name is Dr. John Peterson, Associate Professor of Education Administration. And most of you know, or some of you know, maybe a lot of you don't know, I have an unusual hobby in the summertime. And I catch sharks with my marine science college friends, the SOFO Sharks Research and Education team. And usually at the end of my 3-week stay, we sit around and talk about what they're going to do in the off season, what publications they're going to work on, things like that, and where they're going to present. And this year, at the end of my stay, I said, well, why don't you come to ENMU? And Greg said, why not? So I came back in August and pitched the visit to Dr. Lorenz, and he graciously accepted. And Dr. Johnston graciously invited them. And with the hard work of Melissa Braz, who deserves a hand, 5 months of work, tonight is the culmination of those efforts. So without further ado, I'm going to introduce Mr. Greg Metzger, who's the Chief Field Research Coordinator for the SOFO Sharks Research and Education Program.
All right. Thank you, Dr. Peterson. Appreciate everything. Thank you, actually, for everyone. So we've been on a whirlwind tour here, both in the surrounding community as well as here at the ENMU, and I can say you have an absolutely outstanding community. We've been nothing but welcomed. We've been surrounded by great people that are genuinely interested in who we are and what we do. And so I just really appreciate all the effort, and there was a tremendous amount of effort that went into bringing us here. It's really astounding. All the staff that we've worked with, all the students we've worked with, it's really been a pleasure. So it has certainly not been work to be here. And you are the first audience that we've spoken to that is not getting extra credit, forced to be here. So what I'm going to do is start out with my traditional introduction as when I give lectures, which is here in America, I feel that time is our most precious commodity. And so you guys have chosen to take precious commodities, which is your time to come and spend an hour or two, depending on how long Dr. Peterson speaks, with us today. And I really appreciate your time. I hope that all of you walk away with something, and that the next hour that we have together isn't wasted, because there's a million other things that all of you could be doing. So I genuinely appreciate your time and effort being here. The way this is going to work is each of us are going to speak for about 15 to 20 minutes to explain to you who we are, what we do, our role in the work that we do, and then we're going to just open it up to question and answer. And so we'll be here for pretty much we'll have open forum discussion with questions and answers. I understand that there's some refreshments and stuff like that. So if you guys have lots of questions and are pinning us down, we may end that formal, but we're certainly going to be here and look forward to interacting and answering any and all questions that you have. Before I get started, I have a couple of things that I just will sort of circulate around, because if I don't do it now, I'm going to forget. It won't have much meaning now, but over the course of the talk, they'll have more meanings. These are two of the tags that we use to do the work that we do. These are pop-off satellite tags. This is one, both of these were actually deployed on sharks. We were fortunate enough to get them back. This one had a full deployment. You can see where the paint has been worn, and that's where it was rubbing on the shark's skin as it was swimming around. This one actually pulled out, and so we were able to get the whole full tether back. Again, this will have more meaning if you're paying attention, but for now, just to get it passed around the audience. So that's what those are. These are both dead, so don't worry about dropping them or hurting them, or don't steal them, because they track sharks. So I can just get on my computer and find you and track you down. It'd be very awkward. I know you got my tag, so just save us that problem. Try to return them at the end of the talk. This is a piece of actual shark skin. This is from a basking shark. Basking sharks are the second largest shark in the world. This is one from a juvenile that washed up on Long Island waters a couple of years ago. It was a baby, it was tiny, it was only 19 feet long, and we were able to extract some samples from it, one of which was its skin. This has been dried, but I don't want you to be misleaded. This is what their skin actually feels like if it was alive and kicking. The drying process hasn't changed that, and this is really just to give you an indicator of just how tough these animals are. So that's what those two are. All right, so with that, I'm going to start the show. I grew up very, very far from the water. So I grew up in a small rural farming community in Western New York. We still, to this day, have more cows in our county than people. I was surrounded by farm fields and woods and stuff like that. So my beginnings were a lot like what I've been seeing over the last few days here. I was an avid fisherman. I had access to fresh water. So this was my big prize. This was the big muskie that I caught when I was fishing with my uncle. But I fished in small rivers and creeks and had small ponds and stuff like that. But I always wanted to be a marine scientist. And that marine science inspiration came from this guy. This is Jacques Cousteau, who is no longer with us. He invented scuba diving. He had a show that I was able to hopefully watch at 8 p.m. On my parents' black and white TV with rabbit ears on Sunday nights. And so for those of you that are younger, you can YouTube all of that, what a TV is, what black and white is, and what rabbit ears are. But those of you that are a little bit older can understand. And I was really hopeful that the weather was good, because if the weather was too bad, a little too windy or too cloudy, I wouldn't be able to get enough reception to actually see what was on the screen. It was all like snowy. And this guy was my inspiration, because one week he'd be scuba diving, looking for coral reefs. The next day he'd be on a boat chasing whales. And the next week he would be out looking for sea turtles. And I was like, man, this guy's got a great job. And so despite what my students think, and the job that actually pays the bills for me is I teach high school at a small high school on Long Island. I teach marine research and aquaculture there. And so, my grades weren't that great in high school, but I learned about the Southampton College Long Island campus from my chemistry teacher. I was in 11th grade, sitting there. It was the end of the school year, and the chemistry teacher was pulling internship opportunities off his board. He was clearing his board for the summer, and so he's like, anybody want to be a marine biologist? Ha, 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 as he's throwing it in the garbage, because we're in a rural farming community. Nobody even knows what a marine scientist is. And so I was like, actually, yeah, I'll take that. And so I brought it home and showed my folks, and they're like, well, you've always wanted to be a marine scientist, but you've never seen the ocean. You've never been anywhere near the water, and so this was an opportunity potentially to have that first experience. And so they coughed up the cash and sent me down to Long Island for a week, and I fell in love with the place. It was a small campus, right on the water. They had amazing opportunities. I can tell you that salt water is really salty, and it's unbelievable, despite the gallons of salt water I've drank so far, that anything can live in it. And so, like I said, despite my grades not being that great in high school, they were good enough to get me accepted to Long Island University. And so while I was there, I had a chance to meet some buddies, one of which is sitting here, Dr. Tobey Curtis, so you'll hear about him and his work. There's this guy, Chris Paparo of Fish Guy Photos, and he's a professional writer and photographer. And so he's the one that sort of captures the events and promotes what we do and gives a lot of public lectures and talks about the stuff that we do. This is Frank Corvetto. He's the executive director of the South Fork Natural History Museum, which is the organization that we do our work through. I am a high school science teacher that loves to fish and have summers off, and that's the time of the year when the sharks that we're interested in are there. And then we have Dr. Tobey Curtis, who went on to get his PhD in shark research. And so he's our scientist that makes sure that the work that we're doing is scientifically sound. And so the four of us together, each having our own expertise and interest, were able to start this shark adventure that you're about to hear about. When I graduated LIU Southampton with a bachelor's degree in marine science, I fell in love with teaching. And I said, you know what, I'm gonna go, I felt like teaching high school or elementary school was too like, So I thought, all right, I gotta get my PhD, I gotta get accepted to a program, and I wanna teach undergrads, because that was my 4 years experience. College was all about professors teaching. And so, had a little, hiccup in life. It was 10 stupid points on the standardized test called GRE that prevented me from getting accepted to the PhD program. And I tell my students that those are the best 10 points I never earned, right? Those are the best 10 points I never earned. Because if I would have earned those 10 points, I surely wouldn't be standing in front of you today. I wouldn't have my wife, I wouldn't have my daughter. I have a multi-million-dollar lab that was built to my specs at the high school. And so it's really been a really great ride, So despite what your beliefs are in life, karma, God, whatever it is, a big purple elephant, somebody up there has been looking down, and it's been a really, really great ride. So teaching at Southampton High School. So when I graduated, I went back with Dr. Peterson. He also had a little in life. And so I said, John, what are you going to do? He's like, I think I'm going to go back to school and get my teaching degree. And I said, that sounds like a good idea. So him and I went back to education school, and we both, he went into history and I went into science. And so I was hired at Southampton High School. Coming to Long Island, being an avid fisherman, I of course started to fish, but I was a poor college student. And the only thing I could afford was, to be able to fish from the shore. And I was so angry that the fish I was looking to catch were always like just outside of where I could cast. So it was BC for me, 4 kids and wife, and I had the most money I could ever had in my life. So what did I do? I bought a premier research vessel, right? And I was able to get those fish. They could never be too far away for me to catch them. And so, I bought a boat and a truck, and started sort of at the bottom of the food chain. So I started catching smaller fish in the bay, and then got tired of them. I worked my way up the food chain a little bit, and eventually ended up with sharks. It was really hard to get people to go out on a 17-foot boat to catch sharks in the ocean, but I was able to get enough people that we started to catch sharks. And so the sharks that we caught, I basically, would catch them and take pictures of them and let them swim away. But my marine science background was really bothering me, because nothing's known about sharks. Nothing's known about sharks. Nothing's known about sharks. And here I'm catching these sharks, and I knew that this was really valuable data swimming away for somebody. And so Tobey and I and the group, that the 4 of us, we sort of kept in touch, but not really that great. And so, we were talking. I expressed this, concern with Tobey. He says, "Why don't you join the Cooperative Shark Tagging Program?" It's a free citizen science project that was started back in 1962 by the federal government to do exactly that, just to put tags in people's hands that were catching sharks and letting them go. So I said, yeah, this is great. So this was the first sort of scientific dabble for me. And so what it is, it's basically like a bird banding program. So if any of you are familiar with ducks and geese or any kind of banding, it's a plastic piece of line. There's a metal anchor here that gets placed in the base of the dorsal fin. So the dorsal fins, everyone, is the one that you see and makes you poop your pants when you're swimming. So underneath that, right underneath there, boop, is where we place this dart. And then the tag is bright yellow, so hopefully people see it. And it has a unique number. You fill out the information on the card, you mail it into the feds, and they archive it. And so in those early days, we would catch a lot of blue sharks. And so you can see we just basically stab the small dart into the base of the dorsal fin, and they swim away. And so this is what we were doing. We didn't only catch blue sharks. So this is a small short fin mako that we caught. You can see the apex predator tag there sticking out of it. And this fish sort of changed our attitude and sort of interest in maybe upping our game scientifically. This shark was tagged about a mile off the beach in Long Island. 18 months later, it was recaptured almost 2,000 miles away off the coast of Africa. And so in that 18-month time, it grew a couple of centimeters and it gained a couple of pounds. And so by just putting a simple piece of plastic in a shark, we're able to gain a lot of information, right? Shark from Long Island swims to Africa, it grows a little bit, it gains a little weight. And so we start multiplying this information times hundreds of thousands of sharks, which have been tagged now by this program. You can start to gain a lot of information about growth rates and movement patterns and stuff like that of sharks. But there's a lot of information that's missing. And so Dr. Curtis, he came down and he says to me, he says, you starting to catch some sharks? He said, yeah, that's pretty cool. All right. He says, he said, there's a really good chance that the area you're fishing is a nursery for white sharks. I was like, oh, that's cool. I said, well, what's a white shark? He says, great white shark. I'm like, what? You mean to tell me I could be fishing right here along the south shore of Long Island and catch baby great white sharks? And he says, yeah. He says, and if you can catch them with any kind of consistency, we're going to be on a hell of a scientific ride. Sounds pretty cool with me, right? I was out there fishing anyway, so I was like, all right, game on. So, I am filthy rich as a high school science teacher. And so I upgraded to a really, really premier shark fishing vessel. And so we were off to the races. So we did upgrade to a Parker. This is the 21-foot Pilot House Parker. This is our current research platform. It's still pretty small in terms of boats, but it was a little easier to get people to go out shark fishing with me. So 2015, we're out. We're armed with a pop-off satellite tag, similar to the one that's passed around. We have permits because white sharks are prohibited, so you need permission from the feds and the state to alien abduct them. And so it was the end of the summer. It had been 3 days since we saw a shark, let alone catch a shark. And I was starting school in just a few days. We had not caught a baby white shark. And we were just about ready to pull the lines. And one of the crewmen says, I think I saw a small fin by the float in the back there. And so shortly thereafter seeing that fin, we had hooked the shark. And so I could tell that it was a small shark based on the way it was fighting. It came up. We saw a white belly and the profile of that. I says, okay, we have a small mako shark because that's typical of the time of year. It was the right size, was the right profile, until it came up dorsal side up. Once it came back side up, I saw it was brown and not blue. And there's only one shark in our waters that has the profile of a mako shark with a brown back, and that's a baby white shark. And so this is the first ever baby white shark tagged with a satellite pop-off tag in pretty much the entire Atlantic Ocean. You can see we've got our apex predator tag on the one side, and we put the pop-off tag that was donated to us on the other side. And so although we spent hundreds of man hours and countless numbers of days to try to get this animal, all of our work is interested in a shark being fat, dumb, and happy. So our alien abduction needs to be as short as possible. And so about 8 to 10 minutes is what it takes for us to do our work. And so we let her swim away. And what was significant is, like I said, that was the first ever pop-off satellite tag baby white shark. This is the first ever movement of baby white shark in the Atlantic. And so we had proof of concept, right? We could go out, we could catch baby white sharks, we could tag them. And so now that really jump-started us in moving to the sort of scope and scale of research that we have now. And trying to catch more of those baby white sharks, we catch a lot of other species of sharks, such as the common thresher shark, the sandbar shark. This is Dr. Peterson with a smooth hammerhead. We have scalloped hammerheads. This is Dr. Peterson with a very large sand tiger shark. We have spinner sharks. We have dusky sharks. And so what's significant about this picture is Dr. Peterson has charged the SOFO Shark Research Team with a very lofty task. He wrote a grant that required us to catch him 300 individual sharks in 4 years. 100 dusky sharks, 100 sandbar sharks, and 100 sand tiger sharks. And when this sort of scope of work went out into the shark scientific community, we were literally laughed at the potential of even coming close to this. And so I'm very happy to show this publicly in any chance I get, because that is the 100th dusky shark that we caught last year, which was year 2, even though we were given 4 years. So it's kind of like, sorry to all those haters out there. So this is a very significant fish, and it was really awesome to have John there to be a part of it. We also caught started catching new sharks. So this is a shark nose shark. I had never caught this shark before last year, 2 years ago. So 2 years ago, despite the hundreds and hundreds of sharks I caught, and over the 15 to 20 years I've been catching sharks, when this one came in, I knew it was something different, but I didn't know what it was. So we took 1 million pictures and I sent it to Tobey. And what was cool is he wasn't even quite sure. So he had this circulated around our shark, our little larger shark network, and it came back with a shark nose shark. We also get some really wacky ones like true tiger sharks. We've only caught 3 of these, but it's pretty wild to see these southern species. We bring a variety of people out with us. This is Johnny, diehard shark lover, right, his entire life. And this is the first time he's ever had a chance to actually see and touch a shark, despite being a diehard shark lover. He's about, 10 or 11 years old. As a high school science teacher, my students have free and open access to come out with me. You'd be surprised how many don't take advantage of that. But the few that do, it's not a spectator sport. They're out there doing the same work that we would do whether they were there. This is Kaylin with her first shark. This wild and crazy group did some fundraising and wrote a grant, proposed a grant, and was awarded to put a spot tag. So this is a tag that bolts the dorsal fin of a shark. And whenever that shark fin breaks the surface, it gives us a satellite ping. So we can kind of follow the shark in real time. We did not catch the right species of shark for that last season. So it's currently collecting dust on my shelf. We're hopeful that this field season we'll be able to get that deployed. We do a lot of outreach. And so this is a concept that I heard about that happens in California. It's called the Shark Shack, and I thought this would bring to New York. Since in the last years we've had some naughty sharks in New York that have nipped a couple people, and so we want to try to get ahead of the Jaws mentality. We don't need people throwing dynamite on our sharks. We don't need shark killing or any of that crazy stuff. And so it's literally a pop-up tent that we can set up on the beach with our tags and information and answer questions and tell stories of harrowing shark adventures at sea. A very powerful tool to literally get at the community and try to tamp down some of those crazy ideas that people inherently have when a shark is naughty. All of our work requires us to catch the shark. So here's Dr. Peterson, Dr. Peterson. The shark just jumped on the line, getting ready to battle the beast. And so once we get the shark, the idea is that we bring the shark alongside the vessel. At the initial time, we just have it secured with a hook in its mouth, but that can easily pull out. And so what we want to try to do is get a tail rope around it. So by Dr. Peterson's left hand, you'll see a tail rope. Once we get the shark tail roped, it's not getting away even if the hook pulls out. And so then we go into NASCAR pit crew mode. And so we have a variety of things that we do to it. We take a bunch of length measurements, girth measurements, sex. Dr. Peterson's here is getting ready to take a fin clip. We take a cloacal swab, which is basically a poop scoop, to look at the DNA of the poop so we know what the shark has eaten. We take blood from the shark, and then we have a suite of tags that we affix to them depending on what size and species. The variety of tags vary. These are the pop-off satellite tags, which is the workhorse for Dr. Curtis's work through the museum, as well as these CAT scans. And these are acoustic tags, which is the workhorse for Dr. Peterson's work, which they'll explain sort of a little bit more about how it works and what it looks like. The acoustic tags do need to be surgically implanted. So this is one of Dr. Peterson's grad students, Brittany Scannell. She makes a small incision in the body wall, and then that acoustic tag is inserted in a couple of stitches, and the shark is on its way. Here's Dr. Curtis with a pop-off satellite tag getting ready to go out. These get anchored in the same place as the apex predator tag. They have a large anchor. It basically gets stabbed into the side of the base of the dorsal fin. The shark swims away with the tag. The tag records temperature and depth every 10 seconds for 28 days. After 28 days, it pops off, floats to the surface. We don't have to get that tag back to get the data. It'll transmit the data to a satellite that emails us, but that happens at 5-minute resolution. If we're lucky enough that the tag washes up on the beach or somebody finds it or we're able to recover it, we can download the full 10-second resolution. And we're lucky that our sharks stay close to the beach, and we have an onshore wind most of the time, and we're running about 50% recovery on those tags, which 2 of them have been circulating around. So this is a short little video of what it looks like in the final minutes of securing and tagging, in this case, a thresher shark. The angler is another boat captain. There's three of us that have our own boats and crew that go out to do the work that we do. I certainly can't do it all myself, although my boat does whip the pants off the other 2 captains combined. Any that they catch just helps to reach the goals that our scientists set for us. What's great about thresher sharks is that long upper lobe on their tail. And so what they do is they use that to smack small prey items and stun or kill them, and then they come back around and slurp them up. The unfortunate part about thresher sharks is they're the hardest, strongest, most dangerous shark that we interact with. They can use that tail to defend themselves, which you'll see it try to defend itself against me in particular. That they're not wildly just flapping that tail everywhere. They are very good at pinpoint precisely trying to hit their target. Our goal is to tire the shark out enough that we're able to get that tail rope on and secure them without them hurting us, but not so tired that when we let them go, they're so exhausted that they may not be able to recover. So here I am trying to get that tail rope on. So despite the size of this shark, it is still immature. So this is still a baby thresher shark. I purposely came up with this tail roping technique for when we interact with thresher sharks, and I instill in the crew every shark we treat as if it's a thresher shark. So I make them tail rope every shark species regardless the same way, so that if and when we do get a thresher shark, it's rope memory, it's memory, muscle memory to be able to tag it. As you can see, you would not want to be close to that animal as it's trying to defend itself against the alien abduction. In the early days, we tried to oxygenate the shark, but we found that was just more of an irritant to them than it was worth. This is me putting a pop-off satellite tag on that shark. And then the next tag that'll go on the other side is our most sophisticated tag, which is a CATSCAM. It stands for Customized Animal Tracking Solutions. This is basically like a Fitbit for a shark. It has several sensors in it. It gives us the angle that the shark is moving at in 3 dimensions. It gives us the acceleration in those 3 dimensions. It also has temperature and depth. It has a magnometer in it, and it has a high-definition camera. So you're literally riding the back of the shark, as well as collecting every single movement of its body. We have it set to record all of that information 30 times per second. So we literally get millions of data points from one deployment. So we're just making sure that this shark is swimming, and then we cut them loose and away it goes. The downside to this tag is we have to get it back in order to get all that data. And so in the back of the tag, there's 2 additional tags. One's a satellite tag. It talks to a satellite, so no matter where in the world this tag pops off, we'll be able to know where it is. But that tag technology uses a different satellite system than your cell phone, so we might be a mile away from our tag. And so you're not going to find a pop bottle if you're a mile away from it in the ocean. So there's a second tag in there that emits a radio ping, and so we can listen for the radio ping, and that will bring us to the tag. And we don't want to go losing these because they come at the low cost of $12,000 a piece. 12 grand, so you don't want to go losing these on a weekend. You know, our budget is not able to sustain several CATSCAM losses. Luckily, we haven't lost any. That's another really bad part of the work that we do is the tagging is brutally expensive. So it's $12,000 a piece for the CATSCAM. Those tags that I passed around are $2,000 a piece. Luckily for Dr. Peterson, though, he's got the cheap tags, only $850 a piece. Granted, he has to buy 400 of them, but you know, he's got the cheap deal. We have had the opportunity to deploy cats on sand tiger sharks and spinner sharks. Dr. Curtis is going to show you some leaving a tease, so you don't want to fall asleep or go away because you want to see what it looks like riding the back of a shark, right? Right? I'm setting it up, and so Dr. Curtis has that as part. Like I said, I can't do it alone. This is Captain Walt doing his thing with his crew as a small dusky shark. I also want to give a shout out to Captain Matt, who's the other boat captain, because I can't do all this work alone. With that, I'm going to pass it off to Dr. Curtis, who's going to tell you, now that we have all this raw data, what does it mean, why do we care, and what can we do with it?
All right. Let's see how this goes. Thank you, Greg. Thank you. Thanks everybody for coming. This is really exciting and it's been a really fun visit. My background, I grew up in central Massachusetts, similar to Greg, kind of landlocked. Not quite as far from the ocean, but I grew up on a freshwater bass pond. I love bass fishing, top water bass fishing. I don't know, anybody bass fisherman, you like fishing top water for bass, like it's a blast, right? And then I found out that fishing for great white sharks is very similar to fishing top water for largemouth bass. You just need a bigger jitterbug. So in this case, we actually, for studying large white sharks, we use these like plywood seal cutout as our like popper. And it gets the sharks to jump out of the water. And then when they're swimming around your boat, you can tag them. You'll see the theme here is that we do a lot of tagging, and it's really about, and that's my background, and the projects I've done are all about tagging sharks and telemetry, studying their movements, because if you know where they are and when they're there and how they're using their environment, you can better protect them, you can serve the population. But it all starts with getting some of these tags out, understanding their migration and movement and habitat use patterns. So as Greg said, we all met in college, and then I kind of, I went and got my master's degree at the University of Florida studying bull sharks. I got my PhD at the University of Massachusetts studying basking sharks. But the white sharks have always been my kind of primary love, my primary interest. And so about 10 years ago, I published this paper with a number of colleagues where we compiled everything that was known about great white sharks in the Atlantic Ocean at the time. And it wasn't a lot. We went through all the literature, all like fishery reports, newspaper clippings, and we found about 650 total records of white sharks in the Atlantic in recorded history. So we wanted to look at their distribution, seasonal patterns, and things like that. And so every dot there is a white shark record, and you can see that they range from Canada all the way to the Gulf of Mexico and into the Caribbean. And but they're kind of clustered. Most of the records are coming from the Northeast, from like New Jersey up into New England. And so we're trying to figure out like, all right, how can we study white sharks? Like I had the opportunity to study them in California and in South Africa, where you can go out with your jitterbug and try to lure white sharks up to tag them. But I also, for my master's, I studied juvenile bull sharks, and I really am passionate about studying juvenile sharks because juvenile shark populations are critical to sustaining adult shark populations. You have to protect the little ones first. So we went into the data set, and this is Cape Cod, Massachusetts. This is where we see a lot of large white sharks these years, in more recent years, because there's been a recovery of seal populations. If you watch Shark Week or National Geographic, maybe you've seen some folks trying to tag white sharks off Cape Cod. It's kind of a new hotspot. But where do these big white sharks come from? So we mapped out where all the little white sharks are, and it turns out there they are off of New York, off Long Island, where it was our old fishing grounds when we were college kids. And so that's where I got reconnected with Greg. I showed him this map, and I said, look, this is the only known white shark nursery area where you can find baby white sharks anywhere in the Atlantic. We wanted to find out, is this really a nursery area? And so I had that question, I had the data, we had some breadcrumbs to see if we could find them. But I just needed a boat. I needed somebody who's willing to go chasing these things in their spare time. And so thankfully, Captain Metzger had his summers off and was willing to go on this wild goose chase. And again, this is all about the telemetry. And thankfully, the shark tracking technology has advanced so much since the days of Jaws. We don't need harpoons and kegs to track sharks anymore. We can use these cool tags and pop into them, and we have satellite communication and things things like that to really help us follow them, so we don't have to follow them in this fashion anymore. So there's that first white shark that Greg tagged, and that got us off to the races with the baby white sharks. It's proof of concept. So we were able to start building a collaborative team. I have a number of colleagues up and down the coast, including some good friends at Florida Atlantic University. And then we were contacted by OSearch, which is a research organization, and they sort of tag and track great white sharks all around the world. And they reached out to us, and they were interested. Hey, like, you found this baby white shark, maybe we can tag some more. And they came for 2 summers, and we were able to tag another 20 in two summers with those fin-mounted satellite tags. When you talked about where it has an antenna that comes up, and so when the shark's finning at the surface, we get the satellite pin. So this is just an animation of the tracks of those 20 sharks during the summertime off Long Island. And you can see that they're mostly bopping up and down, kind of running parallel with the shoreline of Long Island, and occasionally making visits further offshore, but they're generally staying relatively shallow, relatively close to shore, and kind of moving up and down the coast. And so when you put all of that information together, kind of in one map, all the dots at once, we were really able to define the bounds of the nursery area for a baby great white shark. And this is the only place in the entire North Atlantic Ocean where there's this many baby white sharks hanging out in the same place. There's no other place like it. So this is really able to help us establish how unique and special, like the coast of New York was, for the entire Atlantic great white shark population. So very small, discrete area, and that's the sharks. For whatever reason, the baby white sharks love this spot. So then the question becomes like, well, what next? We kind of figured out the where and the when, which is a great first step. We need that. But then I'm interested in how, more of the ecology, like, how are they using the water? We know where they are geographically on the map now, but how are they using that piece of water? And this is where the third dimension comes in. So I love Jaws 3D. It's my favorite B movie. The third dimension is terror, right? So, but all fish live in a vertical environment. It's a 3-dimensional environment. You can pinpoint them on the map in 2 dimensions, but there's also depth to the water, just like birds. They can fly at different altitudes, right? So we use those pop-up tags to help answer that 3rd-dimensional question, the dive behavior. What kind of depths do they prefer to hang out at? Other depths they avoid? Are there temperatures they prefer? And we get all of that from these pop-up tags. So, we can start answering questions like, all right, so maybe what's foraging behavior? How are the sharks foraging in these areas? Are they targeting surface-oriented bait fish, like big schools of fish, or are they hanging out closer to the bottom and eating bottom fish, like skates and blackfish and things like that? There's also a lot of fisheries in the Northeast, a lot of seafood industry. So there's a lot of fisheries for flounder and squid and things like that. And the sharks are exposed. They're occasionally caught as bycatch in some of the bottom trawls and gill nets. And so using our tag data, we were also able to answer these fisheries management type questions and actually estimate the vulnerability of these baby sharks to fishery bycatch. Drones are also expanding in use everywhere, but especially in the marine environment. So counting marine mammals, sea turtles, and actually sharks. So this is our friend Fish Guy Photos again, Chris Paparo, and he flies a drone all summer long. And there's these big schools of bait fish called bunker along the South Shore of Long Island, and you see sharks often, but we don't know, when he sees a shark, how often are those sharks actually at the surface? These tags can really help, fill in the blanks on that question. So this is just a snapshot, an example from 4. So each row is an individual white shark. So this is 4 white sharks over the same 48-hour period off Long Island. And you can see that those top 3 sharks are actually doing very similar things. They're the same kind of temperature of water, right around 70 degrees Fahrenheit. And they're staying on the bottom through most of the daytime. And then when it gets dark, through the night, they're bouncing down, very vertically active at night. So it seems like there's something they're foraging on, maybe it's squid, maybe some other kind of fish, that's vertically active at night and then on the bottom during the daytime. So the 4th shark on the bottom is doing something very different. It's in a different piece of water. The temperature structure is different. It's diving a little deeper. It's using some colder water. It has a completely different dive pattern than the other 3. So we're starting to tease apart how the sharks are using the environment, and we're finding that it can depend on temperature and prey availability. And we're trying to tease those things apart to really understand not just where they are, but what they're doing in these places, and then what's driving those patterns. And so when we have this ability to double tag sharks like this, we can actually reconstruct 3D tracks, which is very difficult to do. It takes a lot of data and multiple tag types. So we can, we've been able to do this with the baby white sharks in New York and recreate these 3D tracks. And we're trying to build out this kind of a data set for multiple species now. So we can understand how all these different shark species that hang out off Long Island, how they're sharing this one, bit of habitat. Another important element of our research is looking at the temperature data. So this is an example of how we can use temperature data from the tags to make inferences about climate change. The mid-Atlantic coast of the United States is warming at a rate much faster than the rest of the global ocean. We've seen it with our own eyes over the last 20, 30 years. There's new species. Summers last longer, so the fish are hanging out longer. They migrate later in the fall than they used to. But just this one shark, you can see it's hanging out in that sort of room temperature, comfortable yellow temperature. But when it hits that hot water, about 25 degrees Celsius, it avoids it. It seems like it doesn't like it. It starts diving down into cooler water to cool off. So that 25 Celsius temperature is a temperature they may avoid. And if the region becomes too hot, if that hot temperature shows up more routinely off Long Island, they may start moving out of the nursery area. And then if they move, they could be exposed to other threats like fisheries and predators and things like that. So multiple species. Like Ray pointed out, we have access to so many species, and it's just amazing that you can go out, you can fish in this basically the same place, same gear, same bait, and you could come up with any number of like a dozen shark species. And there's a number of shark rays and skates in the region as well. So it's very diverse sharky habitat. And it's been historically, the sharks have always been there. They've just really been understudied. And now we have these cool new tools and gadgets that we can put on them to understand how they're using this important habitat. So, and now that we're tagging multiple species, we're starting to figure out how they share that habitat. Each species has its own kind of depth range, depth preferences, and there might be individual variability and overlap, but generally each species has its own kind of vertical behavior. So we're really starting to tease apart that how question again vertically. And that gives us that number we can give to the drone operators too. So we can look at this and say, well, what's the likelihood of seeing a white shark with a drone? Well, if you look at the white shark line, they're at their average swimming depth is 10 meters, and they're only spending about 5% of their time shallow enough where you can see them with a drone. So if you see a white shark with a drone, that's like that 5% chance. There's only 5% chance you're going to see them. For other species, it's much more common. Hammerhead, all the way on the left there, they spend a lot of time at the surface. So you're likely to see them more often. So continuing in that kind of vein, with the work, we want to just learn more about the how. And that's where these CAT cams come in. This is just an example of a plot of a snapshot of data, generating millions of data points, 30 times a second. That's the acceleration and the position of the shark. You can actually get their tail beat frequency. You can estimate their metabolic rate this way. So some really fascinating applications with these like shark Fitbits that cost a lot, but you get so much data. And then here's the teased video. Here's the shark's eye view. This is a spinner shark that the CAT cam went on. And we can, with the video, we're not just looking at the data. The data is awesome, but we have to guess like what they're doing. Like, are they swimming with their buddies? How often does that happen? There we go. Just loop that one more time. So when you get the shark's eye view, you get that extra, visual insight. Like we can guess vertically what they're doing, but now we can actually see what the shark sees. What is it hunting? How frequently does it feed? Does it hang out with its own species a lot? Does it bump into other species? And we've also started using baited remote underwater video systems, or BRUVs. And it's basically putting a GoPro on a chum basket and sticking it in the water. And in this case, it's a 360 camera. And so this is great for our data collection and understanding where these sharks hang out and when they're present. But it's also a fantastic outreach tool. Visuals, it's fantastic for education and outreach. And in this case, you can put on some VR goggles and do a virtual dive and have a little baby white shark bite your face. So it's just cool. It's fun. It's valuable data, but the impact of this kind of video observation is just immeasurable. So and then we've done this a bunch of times. We get mixed species, but you can learn a little bit about the shark's behavior. You can see it's kind of wary. It makes a run, then it kind of disappears into the fog. You can't see it, and all of a sudden, boom, it's right in your face again before you even know it's there. Excuse me. So Greg mentioned we're also working with a veterinarian. This is Dr. Harley Newton. She's our kind of vet, consulting vet. And we draw blood, and she's able to do all kinds of stress and health assessments and analyze the blood to understand how stressed the sharks are when we're capturing them, and then generally how healthy they are. Excuse me. And then a couple summers ago, we've started to have some luck and build our network and make some connections. And National Geographic producers reached out to us, and they wanted to film us deploying one of our camera tags, or actually a new type of camera tag on a baby white shark. And we're just, blown away. What a fantastic opportunity. And so the film was released this past summer during that Geo Shark Fest. Baby Sharks in the City is now available on Disney Plus or Hulu if you get that. If you're really interested in what we've been talking about, I really encourage you, we're not getting a percentage or anything. Just go check out the video. It gives you a very honest look at how hard it is to do the research, but you can see what it's like on the water, what it's like on the boat, what it's like to capture a baby white shark and get these tags on. But that was a great opportunity, and it's just exploded our reach. It just started with 4 college buddies trying to do some cool new data collection with these sharks in our old backyard, our old stomping grounds. And it's just sort of snowballed into this wonderful scientific collaboration, and we've just been able to expand our outreach. And and this is part of that too. So we're really just grateful to be here and share this story with everyone. So to summarize my part, New York is just a fantastic place to study sharks. There's so many shark species around, and we're starting to learn a lot. It's kind of a new golden era of shark research in New York specifically. We got a great team of collaborators, and we're using cutting edge technology to answer really important questions, not just about the sort of pure ecology of these species, but answering important questions for conservation and fisheries management. And then education and outreach like this is really critical to our mission, and we really enjoy being able to engage with students across the board and the public wherever we can. So with that, that's the end of my piece, and I'll turn it over to Dr. Peterson.
Thank you. You still with us?
Oh, yeah.
Breath? All right. So I'm Professor Peterson. I teach at Stony Brook University. And very similar to Greg's story, I grew up in Omaha, Nebraska. And so I was surrounded by waves of corn. But I would watch Mutual of Omaha every Sunday night and watch this guy as well. And what amazed me was you could watch Jacques Cousteau breathe underwater and live in a world that was different than the one that we live in. And it just captured my imagination so much so that I made my single mother take me and get certified when I was 13 years old. We were diving in quarries and lakes together, And I thought about this a lot. Do you guys remember the opening scene of Jurassic Park? Do you remember when the lawyer's trying to find people to go to the island and he's in Mexico and the guy digs out the amber with the insect? He said, "Oh, you'll never get him." Well, why won't you get him? Because he's a digger like me. And I feel like that. I feel like I'm a digger. What I like to do is I like to spend time in the field. And as an undergraduate and graduate student, I just fell in love with the idea of collecting samples in the water. And I still do. This is mostly how I spend my time. And I got a bunch of yahoos like these guys in my lab that go out and collect data underwater with me. So this is a picture of the undergraduates and graduate students in my lab up in Stony Brook University. But we do a lot of stuff. I work on seagrasses and coral reefs and oyster reefs. We've got people that are interested in water quality and kind of restoration ecology and climate change. But I got a number of students that are interested in this predator-prey interaction. So those guys like to make fun of me and call me the shark botanist, but you know, I do am very interested really in community ecology. So my interest is in how different species interact with each other and how that changes. And sharks are just large predators in the system. Well, I also teach a class every January in Jamaica. And so Global Finprint, they came and they got a hold of me because I was spending every winter in Jamaica. And you might remember about 6 or 7 years ago, there were a bunch of rich guys drinking cognac and smoking cigars. And they asked each other, I wonder how many rhinoceroses there are in the world. Well, they paid people to literally go out and count every rhinoceros, right? After they had gotten a number of that, how many rhinoceros, they then thought, I wonder how many sharks there are in the world. And they went to the shark, experts, and they're like, there's no way we can tell you how many sharks there are in the world. But what we can do is we can go to 300 locations around the tropics on the globe, and we can drop these beta remote underwater video cameras and come up with an estimate. And since I was spending a lot of time in Jamaica every January, they came to me and asked me if I would do the drops in Jamaica. So we did it in 5 different locations around the island. The first 4 that we did, I found 1 shark. We did 40 drops at each location. So after 160 drops, I saw 1 shark, and it was a tiger shark smaller than me in 4 feet of water in a seagrass bed. And everyone said, well, you're not going to see the sharks unless you go to the fishing grounds, which are 90 kilometers south of Kingston. So we went there. And this is the first beta remote underwater video, the first drop that we did in the Pedro Banks. That's about a 3-meter tiger shark. So we went to go pick that drop up, there was no bait, and the arm was bent at a 45-degree angle, and we're like, wow, something's different here. And that kind of started our adventure with the Peterson lab in the shark world. In my lab, there are really 2 kind of large areas where we deal with sharks and large predators. One has to do with the offshore wind, primarily because of the cables that they're using to bring power to land. And then also the artificial reef program. The South Shore of Long Island is basically a desert of sand, except for where hard material is dropped. So they'll drop things like tanks and armored personnel carriers or vessels or Tappan Zee bridge material. And then in this desert of sand attracts things to both grow on it and things to live there. So I'm going to show you just a quick video here of the sinking of a vessel. So because of our relationship, I get to go put GoPros on these things before they go down to the bottom. And so this is one of the vessels that they sank on one of the artificial reef areas. And then once this drops to the bottom, after about 15 minutes, it gives it all clear, and we'll dive down and recover the cameras. But what captures my attention is within that 20 minutes, that thing was at the surface, and 20 minutes later, I can go onto a vessel that they've just put down, and there'll be fish that have been associated. They're in the area, and they just immediately will come to the structure. I'll give you just a short clip of another video where this is a vessel that was, this is a year plus at the bottom, and what you see is it's just completely just encased with black sea bass and blackfish. And if I let this go long enough, you'd see a cod swim by. And the point really of the video is just how these fish are so associated with this hard structure in this desert of sand off the South Shore of Long Island. And so what I'm interested in is, Tobey's watching these sharks move up and down the coast, and I'm wondering, well, are these sharks basically using these artificial reef areas as like, McDonald's? We stop, get a snack as I'm moving down the road. We currently have 55 acoustic receivers. I'll show you what these look like in a second at these different, so all of the artificial reefs on the South Shore have these receivers on them, and they are placed in such a way that not only do we have one that will say, okay, there's somebody here, but we have multiple ones, And so if a tagged animal comes in there, we can track in 2 dimensions where they move, or 3 dimensions depending on the tag that they have. And so this is what these little receivers look like when they're attached to a boat underwater. But not all of them go on a boat. Sometimes we just put them on an earth anchor and sink them down into the sand. Now these, I kind of like to think that those guys over there, they don't really work all that hard. They do have to catch the fish, but their receiver, their things just pop up. They don't have to do anything. Me, I have to go down underwater and swap these things out twice a year, every spring and every fall. So I do think I work a lot harder than they do.
You saw how many people were in his group, right?
So these are the acoustic tags that I use. And the small ones, like this little tag right here was placed in a fish about the size of my hand, right? And then the one below it was put in those fish that you saw inside that ship just a moment ago. And the big one on the bottom, those are the ones that we surgically implant into the large predators inside the sharks. And I'll get about 6 or 7 years of data from that tag, depending on the temperature of the water and the life of the battery. So if I've got a receiver and I've got a fish that has a tag in it, every time that fish comes within 350 meters, I'm going to know that he's present there. So if I have multiple fish and multiple receivers, I can basically, it's kind of like where I come from, we have the easy pass. So every time I go over a bridge or I go down the road, I get a beep, you owe me $12. It's the same kind of thing for these tagged fish. I have a unique code. It tells me who was there. It tells me when they were there. And if I have enough receivers, I can go exactly where they were in the water column. So this is one of those 12 artificial reef areas. You can see the different kinds of material, railroad cars and boats and tanks and stuff. That's that hard structure that we have in the area. Now, what you're looking at now is the entire summer of one black sea bass. So each of those dots was a timestamp of where he was, and you can kind of congregate the number and density of those dots, and we wrote lines around the 90%, where they spent 90% of their time, right? And they spent a lot of time on this 112-foot steel trawler, right? Spent a lot of time over that steel barge number 335 and around there. So this gives us an idea. What the state really wants to know is, are these fish associated with them, and how does that change over time? Because you put something down right away, and a bunch of blue mussels will coat it. That's a good food resource. But over time, succession, we get towards things that aren't quite as a great, valuable food resource. So maybe there's a life of how valuable these are in time. But of course, we don't have just one black sea bass. Here's a picture of 4 different fish in that same area and how they kind of moved around over the course of last summer. But we're just scratching the surface with this. This is the ship is a cartoon, right? We just put it in there. But the actual movement of the fish, there we go. That's actually the 3-dimensional movement of that black sea bass over about a 4-hour period. So there is an actual vessel there that he's swimming around. These are very data intense kind of models to run. So it's really hard to have something run for, a whole summer. It just takes too much of the data. But this will give you an idea of what we've got tagged, all different kinds of species. Striped bass, big important commercial fish for us, and recreational fish. Well, there's about 350 of those guys tagged between me and another lab at Stony Brook. But because I'm here with those guys sitting over there, all they care about are the sharks that we have tagged. So we've been tagging dusky, sandbar, smooth dog, and sandbar. So over the last 3 years, they've consistently caught 131 sharks. I put 82 acoustic tags in the first year. They caught 26 the second year. This last year they caught 156. And so over the course of the last 3 years, I've put out about 300 acoustic tags on sharks off the south shore of Long Island. Now I know this is a really hard graph to show, but I'm very proud of it. I'm just going to walk you through it. Each of these lines is a different one of those 12 artificial reefs off the south shore of Long Island. And each of these lines is a different shark. And you can't read the names of the shark, but just follow me with this one. Right here is a sand tiger, right? There's a number inside, there's 43. What it says is there have been 43 sand tigers associated with this one, right? But the yellow color tells you they weren't there very long. The darker the color, the more time you spent. And we go to the artificial reef that's right next to it, well, there's 34 guys there, but they spend a whole lot more time there than they did here. So the question is, well, why are they choosing some of these reefs over other ones, right? Look at this sandbar shark, right? He spent most of his time for the whole summer kind of around that one particular reef area. So I'm going to give you a story now of just one shark. So, we'll give this Myrtle, okay? So Myrtle is about a 2-meter sand tiger. And what this plot is telling you is that we tagged it in 2022, and it spent its time there over the course of the summer at 2 artificial reefs. Then it left, went down to North Carolina. Came back in 2023, same 2 reefs, was there for the whole summer, went away. Came back in this last year and was at the same 2 artificial reefs. So we have these, sharks consistently showing up year after year at these different reefs. This just tells you that they were present, where they were at, how long where they were there. Now what you're looking at is Myrtle's track on one of those artificial reef areas. So since the timestamp that I get is consistent, I can now plot how quickly they were moving from place to place. So that line, the lighter the color, the faster they were moving. The darker the color, the more time they spent there, the slower they were, right? And so the question is, well, why were they moving here, but they spent time here, and they spent time there, and they spent time there? Why were they kind of slow and turning around in those areas? Well, we go back to that black sea bass that we looked at a minute ago, and you overlay where that black sea bass was with where Myrtle was swimming around, and now you have an idea this guy was spending time really pretty much where the fish were spending their time in the structure, right? Now, I can't tell you that Myrtle ate one of those black sea bass, but I know that they were in association with the structure where they were present. And the question that I really would like to ask or answer is, this foraging ecology. This is why we're doing that fecal swab, to really be able to identify what are they eating. Because what I want to know is how much of the production of these sharks is coming from eating stuff that lives up in the water versus how much of the production is coming from the stuff that's associated with these artificial hard reef areas, right? The good news about the poop scoops is they will tell you very clearly what they ate. We can genetically fingerprint it. The downside is I only get what their last meal was, right? And so when Greg was talking about all the things we do a fin clip. We take the fin clip for a genetic sample, so we kind of fingerprint the population genetics, how related they are. We take a muscle biopsy, and that's really for looking at stable isotopes. So we can kind of get where do they fit in the food web kind of a thing. And I'd like to pair that stable isotope stuff with the kind of the recent meals that they have. So that's how I'm using the data that those yahoos over there are collecting on the fish. And with that, I think we'll just open it up with, no, because there's another very important thing that I do. I forgot about it. And that has to do with the wind farms. And I do want to, because it's a growing issue for us up in New York. Well, it has been recently. We have a number of lease areas where they've been putting these wind turbines up, and they run the cables to Long Island. There's only 2 places on the island that can handle them being plugged into the grid. And so we have basically been contracted to look to see how these cables might affect fish and sharks. Well, the cable itself is encased to basically prevent the electric field from leaving it, okay? But if that cable's turned on and the water flows over it, it creates a magnetic field. And so the question is, how are different animals going to be, how are they going to, that field going to affect them? And so I was, of course, most interested in sharks because they've got these fantastic organs called the organ of Lorenzi that are basically able to detect electric and magnetic fields. And so these are the ones that we really want to look at to see if they're affected. But of course, because of the work that I've also done, I'm also very interested in this hard structure they're putting out, because these hard structures should act just like those artificial reefs. So we're curious, though, right now about how these different animals might perceive that magnetic field. Are they going to be repelled by it? Right? Are they going to go up to it, detect it? And if so, then those sharks that are migrating up and down the coast, that might be a barrier to their migration. However, some sharks actually use these magnetic fields to find their food. So that might be bad if they're attracted to an area thinking that there's food there when there actually isn't, right? So there's two ways that the sharks can be negatively impacted with it. This is just telling you these are kind of the animals at most risk of detecting these magnetic and electric fields, and so that's why I chose those 5 to tag. Here's the array where one of the cables come in. We're looking at both places, but that's one that we have been paying attention to the last 2 years, and so I'm just going to show you data from that. So of the 5 species of elasmobranchs, these 4 sharks we'll fixate on. We've got 100 duskies. Thank you very much for 100 duskies. He's only done 62 though of the sand tigers, and 62 of the sandbars, and 75 of the dogfish. But we're close. We're close. We got a lot of animals. This figure just tells you kind of where they were on the coast when we tagged them. And I'm of course very interested in whether or not they're going through the array. Right? If I'm tagging sharks, they're not going through the array, I'm in trouble. So what this figure shows you is that here's the different sharks, the sand tigers, sandbars, and here they were in my array in August after the year. They were the X's when they were tagged, and here they were in the following year. So all of the different species that I've tagged have been found in that array, and those we can also look at their depth profile because the tags they have a pressure sensor. And so just as Tobey was showing you of understanding the depth of where they were, I'm interested with the acoustic tag because if they turn the power on, the sharks may just simply go up, right? Just kind of go up over the top of it. And that's what we want to know is whether or not their behavior is going to change. So what this plot is, every dot is a position of a sand tiger in 2022 and 2023 in that array. So that's great. We got lots of positions of sharks in that array before the power is turned on. And I can basically create a plot like this that shows 90% of their time through that plot. And that's a sand tiger. And we've done the same with sandbars and duskies. So this, data, we've got the initial data. They're going to turn the switch on this year. Right? So I feel pretty good that we've got an idea of how they're kind of going across that open space right now. And next year, we'll have an idea of whether or not that turn on the switch has any impact on the sharks. So those are the 2 things that my lab is interested in. And I think now we'll just invite those guys up to answer any questions that you have. So thank you for your time, and thanks for coming.
If you are looking to run for the door, I can't say as I blame you, but before you leave, I do have a few stickers left. This has been a hot commodity in your area. There are a few left. I think actually I might have enough to cover everyone that's here. I'll just put these on the back if you have to leave or you want to leave. If you want one, you're more than welcome to take it. There's 2 kinds. There's blue ones. These are not waterproof. The blue ones are not waterproof. And then there's white ones, which are waterproof. So I'm just going to put them back here. If you need to leave, go ahead. But we'll be here to answer questions. You can start firing away. Okay. Yeah.
So why is it called a no-name shark? No-name shark.
No-name shark.
Sorry, there was one that was called a shark nose?
Yeah. Oh, so yeah, the Atlantic sharp nose shark, maybe, sir. So I like to joke that shark common names are great. There's a blue shark. There's a white shark. There's a spiny dogfish and a smooth dogfish. Which one has the spine? So the Atlantic sharp nose shark is otherwise kind of nondescript. They have a few little white spots on them, but they just have a very kind of cone-shaped, long snout. And so, sharp nose shark. They don't get very big. They get maybe 3-4 feet long. But they're much more common down south, Florida, the Carolinas, and they're very rare in New York. So it's interesting that we're starting to see some of those other species come up.
Other nursery areas that are very prevalent?
Okay, so great question. So the question is, is our area other nursery grounds for other sharks? So our work has confirmed that it's a nursery for white sharks. There's another organization on Long Island that's confirmed it as a nursery for sand tiger sharks. And I believe, although it's not published yet, but I think we have enough data to fit the criteria for it to be a nursery for dusky sharks as well. Most of the sharks that we catch are juveniles. They're not sexually mature. There's 3 criteria that you need to sort of prove in order to deem an area nursery for white sharks, and that's there's a higher population of little babies in that area than elsewhere. They spend time in that area, they're resident, so it's not just that you caught that one that day and they're gone. They spend time there. And the third is that it's repeatable year after year after year. And so that's, as long as you can demonstrate those 3 things, you can scientifically deem an area a nursery.
Dr. Curtis, how big is this, dusky gonna get?
Yeah, so duskies are born just a little bit smaller than that. They can reach over 12 feet long, like 3.5 meters, something like that. So the dusky can be a massive animal, and we only catch them about that size.
Thankfully.
And other places in the world that are nurseries?
So there's 2 other confirmed nurseries for white sharks in the world. One is in Southern California and the other is in Australia. We have sort of anecdotal evidence. I was asked earlier today, I think, what's next? Like, what would be the next adventure you could go on? And so we had an opportunity to chat with some white shark researchers from South Africa. And so there's pretty strong evidence that they've got an area there that have the little young of the year white sharks. So it's possible that's another nursery, but hopefully we'll have the opportunity to go and maybe try to catch and tag a couple of those young of the year white sharks in the near, future there.
But in general, there's over 500 species of sharks.
So we have to.
So lots of these, at least the coastal shark species, the one, not so much the deep water sharks or the more pelagic ones, but at least these kinds of coastal sharks that we deal with, lots of them have sort of estuarine nurseries or near shore nurseries, sandbar sharks, bull sharks, things like that. They often have nurseries in bays or estuaries or river mouths or very near shore like the white sharks. It just helps maximize the survival of those pups.
Yes, sir.
Yeah, question?
Is there something environmentally unique about those nursery areas? Why only those specific places?
Yeah, for each species, it's different. So that's part of the big focus, or the initial focus with the white shark work, is like, once we get these tags on, we can start to ask those, help hopefully answer some of those questions. Is it temperature? Is it prey availability? Usually it's a combination of multiple things. There's usually no one silver bullet, answer. And so, but each species has different temperature tolerances or preferences. They feed on different things, and even for the sharks that use New York waters as nursery habitat, they're still sharing it in different ways. They might target different prey or have slightly different temperature preferences, and so it's kind of neat, like I was saying, to be able to start teasing that apart.
Yeah, question.
What do y'all do while you're waiting to catch the right fish?
All right, so great question.
There is a lot of waiting.
So we only show you the highlights. Shark Week and Discovery Channel, they only show you the highlights. They don't show you the hours and hours that you're sitting there doing nothing. So it's a requirement of mine that anyone who steps on my vessel has watched Jaws within at least the last year, because we'll often talk in Jaws quotes. So that you need to be able to communicate effectively. So if you've never watched the movie or seen it recently, you're kind of useless to us. The other thing is, if a perfectly delivered Jaws quote falls on deaf ears, that's immediate grounds for firing on my vessel.
People get hired and fired constantly.
Yeah, you would definitely get hired. You could be hired as quick as you're fired on my vessel. Let's see, what else? Well, we encourage, so if it's slow, there are 3 scientifically proven ways to create a shark bite. We encourage people to start eating a sandwich, smoke a cigar, or fall asleep. Those 3 things are, you can't do them all at once. They need to be strategically spaced so that they maximize effectiveness.
I know you're chasing juveniles. Have you ever caught a full-size giant white or anything like that?
Almost, so we have no control over what's gonna jump on the line when we're out there. You know, the only species of shark that we typically will catch adult of are the sand tiger sharks. So even like that big thresher shark that I talked about and most of the sharks that you saw, you know, they're very long-lived, they're slow to mature, they have to get physically, you know, quite large. So we have had whales die on Long Island for whatever reason. And those dead whales have attracted larger white sharks to Long Island waters. We have that confirmed because drone pilots and stuff have been out there to see that. But even at that, I mean, I don't know that, you know, the white sharks that we saw were estimated 10 to 12 feet long. So unless it was a male, that probably was still an immature.
Still a juvenile.
It is still immature animal. Yeah. So I am very grateful that we do not have, you know, full-grown 600-pound dusky sharks to catch. I just am not interested in doing that. You know, to sort of put it in perspective, and although we joke around a lot here, this is not joking. Like, what's it like to catch a shark? And so the best way I can describe it is take a fishing line and pole and reel and tie it to the bumper of your car and just have your friend drive away. Don't stop, don't look back, just keep driving. And that's really what initially it's like, even if it's a tiny little shark like this. You know, I take safety very seriously on my vessel, and so I have multiple stop gaps that keep people from getting pulled overboard. Dr. Peterson holds the distinction of being the first person almost pulled overboard. He was asleep at the switch. But even this small dusky shark is powerful enough if I have to drag cranked all the way up to pull a human overboard. So I'm very thankful we don't deal with many large animals.
Shark's body is about roughly 50% muscles. Like there's solid muscle, and even a little one just has really impressive pulling power.
You know, and not to make light of what Greg was talking about, everyone on board the boat, whether it's the first time on the boat, everyone on the boat has a job. You know, and it's like 3 hours of boredom, possibly, followed by, you know, 15 minutes of sheer, you know, adrenaline and craze. In that clip you had of Dr. Peterson, when he had the thing on, what you notice, he has a belt on because your arms aren't strong enough to hold it, right? And so the pole goes into that. The belt clips onto the pole so he can let go, right? Not have to hold it. You can use your legs to pull back. You've got someone who's literally at the back. There's a handle there. So my role while he's bringing it in is to just be behind him in case, you know, he does get pulled.
I call it the holy shark handle. The holy, because when you need somebody holding it, it's usually because you're yelling, "Holy shark!" So we have several stop gaps to ensure that nobody goes overboard.
And it really is like a NASCAR pit crew. When the animals finally got a tail rope, and so you've got someone who's holding the leader and the tail rope of the animal, there's other people. Someone's going to get that fin clip, someone's going in to do the blood draw, someone's going in to get that, you know, the tissue hunt. Someone's getting the sensor up, make sure that green light's popping, because the last thing you want to do is put a $2,000, you know, pop-up on someone and not turn it on, right? So everyone has their own job to make sure, because 8 minutes isn't that long, right? So we want to make sure that that animal is off the side of the boat in about 8 minutes, 8 to 10.
Yeah, because again, you know, all of our work depends on, like I said, a fat, dumb, and happy shark. So we want it back to normal as quickly as possible, so it can be interacting with the cables, it can be swimming at those depths, it can be doing the normal sharky stuff. That's our particular group's interest. Oh, another one.
Well, I'm asking for,
Oh, no, come on, you gotta ask yourself. Come on, step up.
she wanted to know what was your favorite accidental capture, another fish or.
Accidental. Okay, so I would say for me, so I've been fortunate to be able to do this and have some luck out there. So I handled, you know, hundreds and hundreds of sharks to this point. And last year, I was surprised with a really great first. So I showed you 2 hammerhead sharks. If you remember, one was brown in color and one was very yellow in color. So that yellow one was a scalloped hammerhead, and that's the first time I had ever seen, let alone be able to catch, tag, touch a scalloped hammerhead. And that's that's one of those 350 species of sharks that is basically completely unknown anything about in the scientific community. So I would say for me, as far as like a unique one that matters, that shark nose is the same thing as the first time I had ever seen a shark nose. I had no idea what it was. I had to take pictures, but it was like a little dinky shark that looked kind of like everything else. To have this bright yellow, like really big hammerhead, that was pretty exciting to me. So scalloped hammerhead. Yeah.
I wasn't sure when you first were talking about the data that's collected. Where did you say the government, or where did you say it went? Or does it just go to?
Yeah, so the thing, all the physical samples, like all the body parts and pieces, go back to Dr. Peterson's lab, and then from Dr. Peterson's lab, some of those might be subsampled and go to other scientists across the U.S. to supplement their question, right? So blood can be 100 different questions can be asked about blood. And to these scientists, the hard part is getting the shark along the vessel. And so we're fortunate that whenever we have a shark along the vessel, that we're able to maximize the science we learn from it. So we will partition those samples and stuff like that. But that's Peterson's lab.
Were you talking about the tagging program, the government tagging program?
Oh, sorry.
That's okay.
Yeah. Yeah, no, so that's run by NOAA. It's the NOAA shark program. It started in the early '60s, and it's the longest running shark tagging program in the world. They've literally put out 3 or 4, maybe 500,000 of those tags worldwide, mostly in the North Atlantic, on a mix of species. There's actually really cool, if you're interested, there's a really cool tag atlas, it's called, in one of the NOAA scientific publications, and it summarizes 50 years of that program. All the sharks that have been tagged, where they've been recaptured. So things like makos and blue sharks, they swim around the entire North Atlantic. They swim into Africa, along the equator, through the Caribbean, and they just kind of do this big circuit. A lot of the other sharks are kind of snowbirds. They spend the summer up in New England, they spend the winter down in Florida, the Carolinas, and they just kind of, you can see from there, those tags and recaptures, just kind of move up and down the coast.
Headquarters for that, so when I mail the card back in, it goes to Narragansett, Rhode Island. So Kate loves me. Kate loves me.
So many tags.
So many tags.
So what are the sharks eating? What's your favorite deal?
Yeah, so for us on Long Island, we have a migration of these small fish. So they get about this big. They're called bunker or menhaden, and there literally will be hundreds of thousands of individual fish in one single school. And so, the schools will just be dotted consistently along pretty much the 180 miles of the South Shore of Long Island. And so it's a tremendous food source that is an easy meal for not only our sharks, but whales and dolphins and ospreys and seagulls and striped bass and bluefish. So they're a really powerful forage fish to help fuel all the sharks and animals that are big enough to eat them in our water. So I always tell people, if you're reincarnated as a bunker, you get something really bad. Because you spend your entire life just running for your life.
So in general, sharks are kind of opportunistic. They'll kind of feed on whatever's most abundant. And in Long Island in summer, those bunker are really one of the most abundant, like relatively easy to get prey items. But there's also a ton of bottom fish. There's a lot of skates, rays, and flounders, and there's a lot of bottom fish. So I think that when they're kind of maybe between these big schools of bunker, there's also kind of all little snacks dotting the bottom too. They can kind of swim up.
Yeah, the sand tiger sharks, those big sand tiger sharks that we catch, oftentimes the sharks just ate something that's causing them really a lot of discomfort. And so one of their mechanisms is to turn their stomach, whatever they just ate that's causing them this crazy, unpleasant experience. We'll oftentimes see things like a common is another small species of shark, which is a smooth dogfish. So that's also a common food source for at least the sand tigers that we see.
And then you also mentioned that they have predators, and so who and what would those be?
Yeah. So really the only natural predator to a shark is a bigger shark. So for our little, dusky sharks or little baby spinner sharks, if there were a larger tiger shark that was in Long Island waters, which does happen those tiger sharks would snack on the smaller sharks. We haven't caught any bull sharks yet, but we do have the first, for our team, confirmed adult bull shark in Long Island waters, close to where we were fishing from a drone footage. And so certainly those bull sharks would snack on the smaller species as well.
It's not, I mean, it's not like all the time, but it's not uncommon in the summer to see a shark or two where there's been like part of a fin taken off, where there's been a bite mark, where another shark is obviously gone after.
Yeah, question?
Have you ever gone down like in a cage to observe?
Yeah, so I actually, being a shark guy, you gotta own your own shark cage. So I actually own my own shark cage. My insurance company found out about it and canceled me. So the new insurance company made me sign a waiver that I wouldn't even mention the word shark cage. So please don't call my insurance agent. So it's awesome to go in. And I was fortunate, my dad and I did a trip to Guadalupe Island off Mexico, which is pretty much the best place on planet Earth to cage dive with adult white sharks. So I strongly encourage cage diving. It's a really great way. Tobey can share stories of cage diving in Hawaii. But, yeah.
Hi, my name is Fernanda, and I would like to know what can I do because I'm from Mexico, specifically from Oaxaca, and I live in a place where every day people fish like hundreds of sharks, and it's like part of the culture, and I know that they are in danger of extinction, and I don't know what can I do.
That's a great question. It's important, and that's a great point. So sharks in general, worldwide, a lot of species are threatened with extinction. They have heightened extinction risk because of overfishing. At least in the U.S. Atlantic waters and Gulf of Mexico, U.S. has a lot of regulation. We've really trimmed back the shark fishing effort. A lot of populations starting to come back. So in the Gulf of Mexico side, there's I think sharks are probably a little bit more protected, a little more abundant. Even if Mexico doesn't have strict regulations on what is harvested or how many quotas or things like that, there's kind of the benefit of the U.S. Having really strict quotas on how many sharks can be caught. It's a tough question, it's part of the culture. People need to eat. It's a good source of protein. Shark is actually very good when prepared well. It's tasty. A lot of it can be about the method that they're caught. If they're caught in the fishery, if you catch hook and line, like a few hooks at a time, you can be very selective about what's caught. If they're using things like nets, steel nets, and trawls, and things that are a little less discriminate. And there's a lot of bycatch that will catch turtles and dolphins and things like that. And so using hook fisheries is better than using net fisheries as a general rule to help reduce the bycatch. So I don't know if you have a way to know how your sharks in your markets, were caught, but if you try to get like line caught, hook caught shark, it's probably less impact than some of the other methods.
Yeah, and also true because I'm from Mexico, so now I like this fishing town called Peterson, and I know some people there, and they tell me like it really commonly catch sea turtles, and sometimes they even tell me they eat them, but because they found it already dead. Not because of the contamination of the seas, basically.
Yeah, so I mean, I've heard that historically sea turtles were harvested and eaten a lot throughout the Caribbean and the tropics. I've heard it's delicious. But it's certainly, the sea turtles, all the sea turtles are basically considered endangered now. So it's certainly not encouraged to eat them, but they still do in some places in the Caribbean. Especially, I imagine, especially if it's one that's caught, it's like fresh and it's recently died, like in a net or something like that. They might not pass it up.
So I heard of that because I was born there, but I live in Sonora. I used to come and usually pitching also the gas companies just poison the seawheel there, like figures this gas station was in the middle of the river. There was like a specific zone, a lot of fishes, species were living there. They got a disaster, and most of the species died there. It was such a mess to clean it up, and it's because it was just oil and all that. Yeah, it was a fire, and all Veracruz is really pissed off with that company. Yes.
Yeah.
Yeah, we just wanted off the state because isn't that part of the sea of the Gulf of Mexico? There's a lot of petrol service down there in the sea.
Mm-hmm.
and also too much traffic of all the countries to their business there, basically all the imports, all that come to the Puerto Veracruz.
So like shark conservation is not easy. There's no silver bullets. Like a lot of things are in need of, it's a wildlife, there's biodiversity crisis worldwide, lots of species, and sharks are not exempt from that. But like some people like to campaign for one specific solution, like, ban finnings or don't eat shark food. Things that sound like they might work, but they're kind of overly simplistic and they don't acknowledge all the nuance. And cultural challenges of trying to implement conservation, and how do you encourage a fishing community to stop fishing for something that is very difficult?
Usually they try to keep it like safe in the aquariums, but usually they die there. They do like I said, marine cows. They used to have one that was in an aquarium and she died. It was already with them, but not in the sea. She died there.
Thank you.
Yeah, thank you. Thanks for sharing. Any other questions that,
We're happy to hang out up here.
yeah, we're gonna hang out, so if we're here, if you wanna come up and talk privately, or if you have like too many questions you want to ask everyone.
Thank you.